We'd like to start today by just asking a couple of questions, really, and they're quite deep and profound questions, but they're, what are the things in life that are important to you? And what will your legacy be? And whilst you have a think about that, we'll just touch on a few of the things that we think are important. So, we're really about designing spaces and places, so the places around buildings as well as buildings, where people are healthier, happier, and more productive. And for us that's really important because who doesn't want to be happy? Who doesn't want to be healthy? And actually, who doesn't want to get that job done just a little bit quicker? And then the other side of that is actually we've got to do it in a way that touches the earth lightly. So how do we create great places for people that are also very resourceful? And essentially, that's what we're going to talk to you about today. And we're going to look at that in terms of refurbishment projects. So,
yeah, it's probably worth just touching a couple of cool refurbishment projects that I've been lucky enough and fortunate enough to be involved in. The Whitworth Art Gallery in Manchester, which won Refurbishment Project of the Year, I think, yesterday, in Building Magazine, with Muma Architects. So this is a Victorian art gallery where we essentially strip back the 60s interventions that were put in place. So removing the ceiling to expose these fantastic vaulted ceilings. Using the roof lights to provide gallery spaces that are really adaptable and that can make best use of the daylight when available. I mean, I should also say that the project itself increased the footprint of the existing museum by about 30%. With a deliverable carbon target of a reduction of 10% from the pre-project. So, fantastic opportunity to really kind of remodel an existing institution. And also, it's really important that these places are open to the public as well. So, you can walk in there. Connection to the park is fantastic. We did quite a lot of work there, looking at the brise soleil. So this is I've got a pointer, with the fins you see there that help shelter the promenade from solar gains in summer months. Integrating heat pumps, labyrinths, earth tubes to bring in fresh air and passively cool it. So you can do some really cool stuff with retrofit and refurbishment projects. We've been involved, I've been personally involved with the Natural History Museum since 2013 on a number of projects, and Phil and I are currently working on their sustainability strategy for their site. And this is a client with a challenging estate. This is part of their estate in South Kensington in London, Grade 1 star listed site, really tricky. So this is the New Earth and Planetary Sciences Centre. So this is to the right of the old Gothic Victorian building. There's a 60s I guess carbuncle, which is their existing paleontology building. So we looked at how can we make that be a world-class research a place for scientists, and also a collection storage place as well. So looking at options to refacade it, maximising natural ventilation to the offices there. So just to kind of reiterate, you can do some really cool, wacky things with retrofit and refurbishment projects. And just to kind of take stock on retrofit and why it's such a challenge, a key challenge that we have to address, is that 80% of today's building stock will be with us in 2050. So in terms of achieving our climate change targets, etc., I mean, it's really a retrofit challenge is what we're talking about.
So what does this mean for our universities? Well, just kind of looking at the higher education sector, it's a huge sector. It has a turnover of 27.3 billion a year, and it's got a capex spend of 2 billion. And just to put that into context, that would put it as about number 4 in the FTSE 350. So there's big opportunity here. There's a lot of money being spent, and actually it's about thinking about how we use that to create great places that are kind to the planet. And one of the things that is, it always blows me away, but when you look at the size of university estates, you've got, on the left there, you've got the Tesco estate. So the university estate is about 7 times as big as that. And then if you take all the government buildings put together, it's about 2.5 times as big as that. And it's just short of the NHS. So actually, if we can make changes to the university estates across the country, we're in a really good position to have a really positive impact. And we also know that it's really important to students. It's important to, quite a lot of you guys in the room. We've done a lot of research looking at, actually, if students were in charge of their estate, what kind of things would they change? And the things that came out in the top 5 were campus connectivity, so actually joining up the buildings on a campus. But sustainability, it was there at number 2. So really, we need to be pushing this agenda. We need to be making sure that the decision makers are considering these things that we all think are important. And then number 3 was refurbishment of assets. So actually, as Oz said, lots of assets have already been built. 80% will be there in 2050. How do we make the most of what we've got? And then architecture and look and feel is really important too. So actually, if you want to be in a nice place, architecture and getting the actual feel of the place is so important. And then indoor environmental quality. I thought it was great what the keynote was talking about in terms of actually if the CO2 levels are high, it's so much more difficult to concentrate. If there's no natural light in a lot of these buildings, it doesn't make you want to kind of stay awake all the time. So really thinking about how we bring in natural elements to the indoor environment. So how do we conceptualize sustainability? Has anyone seen this model of sustainability? No? Okay. So this is the 5 capitals model, and a lot of you might have seen the kind of 3 overlapping circles, and sustainability is the bit in the middle, right? But we think this is much more meaningful, and this says that everything is based inside the natural world. Without fresh air to breathe, without clean water to drink, actually we're never going to develop as a society. We're never going to be healthy. And actually, you need things like healthy people, people who are actually educated, to really develop buildings, manufactured capital, that actually helps improve the other capitals around them. And then what's quite interesting about financial capital is it actually has no intrinsic worth. It's one of those things where if you're in the middle of a desert and you don't have any water to drink and there's nothing around for miles, having £1 billion next to you, it's not going to make one bit of difference. So all that allows you to do is trade the other capitals. So we kind of quite often start off with this model as a basis for developing what sustainability means to our projects. And I think it's important to stress that for like the last 20, 30 years, there's been a real movement behind green building. And I don't think we're doing it as well as we could, but also perhaps some of the people aspects have been forgotten a little bit. So there's been a movement recently looking at actually how you design places for people's health and well-being. There's a new standard that's emerging called the Well Building Standard. And what I think is quite interesting about these things is it's very personal. It connects it to how the building will impact you straight away. And actually, quite often, a lot of the features that are good for health and well-being, creating great environments, are also good from a planetary perspective as well. So it's not necessarily either or, it's how we do both that's important. And I think this can be a great way of actually justifying green design as well. So thinking about how, improved air tightness, good thermal comfort, and those kind of aspects can improve a great place and make it a great place for people is really important. So just going on and looking at how we design for people and why we do it. And really, there's a lot of kind of monetary aspects to this as well. So actually designing places that are healthy reduces the time people are off sick. It improves their mental health. And in our society at the moment, that is a big deal, right? So actually, how do we create environments that make people feel better and help us concentrate? And actually, what might that do in terms of our experience? What might it do in terms of dropout rates, improve research and performance? What if we could do better research because of the buildings that we were in? And then also, the government is touching on it in its new white paper for education. But it's looking at how, essentially, we can become more competitive as a nation through developing better higher education facilities. So how do we conceptualize health, happiness, and productivity? Well, we think it's a combination of what people experience. So what they see, what they breathe, the things they feel, also acoustics, and what is actually consumed, so good food, those kind of things. But really, think about what this means for a building. Actually, a good view can be quite an aspirational thing. It can make people want to be in that space. Fresh air is so important. And again, in terms of thermal comfort, like when it's too hot in summer and you just can't do that bit of work because you're just too hot and bothered. So it's really thinking about how we improve those things. But also thinking about the people and what they need to do in the different spaces. So anything from the business person to the elderly, families, how do we cater for the cross-section of society and make sure that our places reflect what they need to do? So we've taken all these different concepts, and I'm not going to say it's simple, because it's not. There's a lot of different things going on here. We've got things such as how we mass the building, how we actually detail the facade, how we design the heating and ventilation systems, really thinking about the acoustics and actually what impact that has on people, so their performance. How much all this costs. What about the views out? Actually, we shouldn't be thinking about just the building, we should be thinking about its connection to the site. So what we've done is taken all those things and we've put them into a framework which we use to work through with design teams, with architects, with engineers, with landscape people, to really think about how we actually influence the site massing orientation, what impact that has on the environment, and that includes its resource consumption, but also air quality, thermal comfort, lighting. And in turn, those have been proven to have an impact on people's experience. And if you've got people that are happy and productive, then it makes sense that it's also going to be a really good building economically as well. So there's loads of research out there, and we've just summarised a few of the different pieces on a few slides. Just in relation to air quality, there's so much that we can do. So looking at natural ventilation strategies, looking at actually getting the aircon and the facade and detailing right. Actually thinking about what that means in terms of indoor environmental quality. And what's really interesting is those things have been shown to, reduce short-term sick leave. They've been shown to actually improve productivity. And the numbers aren't insignificant, so 8 to 10% in one study on the right-hand side. But what's really, really kind of scary to me is that a lot of the research says, actually, we need to be pushing fresh air rates up to like maybe 20 or 30 litres per person per second. And the British standard at the moment says as a minimum standard, it should be 8. And that's what a lot of people are designing to. Is that going to be creating great, healthy places? I don't think so. So just in terms of thermal comfort, again, there's lots that we can do in terms of minimising solar gain in summer, creating really good HVAC strategies where they're needed, really thinking about what's required from a comfort perspective. So actually, when you go into a building, you don't need it to be conditioned to 20 degrees Celsius if it's a hot day outside. When you come in, that would actually be quite a shock to come into that. So maybe let's let it fluctuate a little bit. Let's let it climb up when it's hot, because when you come in, it'll still feel good. And then actually there's been a lot looking at how that impacts on people's experience, what it does to their heart rate, their respiration, all these kind of things. And there's lots out there in terms of how it impacts economically as well. So, one study looked at just the impact of people having choice on their comfort. And one of the studies looked at that in terms of 3% gains in overall productivity in that space. And how many of us actually know how to adjust the comfort in a room? How can we actually improve that? We've got to get better as designers. Lighting and daylighting, it's huge. And quite often we design spaces that just aren't catering for this. So how do we actually get good amounts of daylight, but also the right quality as well? So the right types of colours. And this is a feature that's been brought in on the iPhone recently. I don't know if you've seen it, but it adjusts the colours depending on the time of day. So you'll get bluer lights in the morning and redder lights on an evening. And we're biologically programmed to respond to that. It affects our circadian rhythms and how we feel and how we sleep at night. And some studies have looked into the impact of that as well. And again, some of the findings are quite significant.
Okay, so I'm going to talk to you about a case study. It's the David Attenborough building, and kind of just talk about a little bit about our approach. This is what we do in most of our projects. We look at, it's called a resource tube map for obvious reasons. So we look at a site and we look at the available resources that there are for that site and look at synergies. So where can the waste process be used elsewhere? Where can heat be used for an absorption chiller, for example? Where can rainwater be recycled for non-potable use? We then adopt a hierarchy for energy, water, waste. I'll talk specifically around the energy space here. So this is, if you like, a 5-step hierarchy. So looking at the site, what are the site's opportunities? What are the prevailing wind conditions? The solar access, solar installation. These might help inform passive design strategies, for example. Orientation and massing, maybe not so relevant for retrofit projects, but where potentially the form and massing can help with reduced energy. Building fabric, number 3, that's really where passive house approach really helps. So where can you maximise taking a fabric first approach, really high levels of air tightness, etc. And then delivering energy as efficiently as possible, and where possible using renewable technology. So that's the hierarchy that we adopt. Thinking about buildings as layers as well. So each layer going from outside to inside the building might have different life cycles. So the building fabric itself might have a life cycle of 50, 100 years perhaps. And then going into that, the services might have 15-year life cycles. So when you look at a project and you're changing an aspect of those layers, it might actually throw up some opportunities to really impact the stuff in the middle of the building. How can you impact social change of that building as well? So thinking as a layered model is quite useful. So the David Attenborough building itself is 17,000 square metre, 1960s building. I would say it's a typical HE stock, but not every HE building has a whale in it as well. So, there's some quite neat aspects to it, but it needs to work quite hard as a building. It's got a lecture theatre space, it's got research space, it's got amenity space. So we carried out a building user survey just to try and understand a baseline in terms of what the building users were satisfied or not with their environment. And actually, in terms of temperature in winter, it's one of the worst buildings ever in terms of building user survey for comfort. Also on health as well, really performing very poorly in terms of, if you're thinking about sick building syndrome and how you want to try and minimise time off. These are really important aspects for designers that we need to address. So there's a pretty poor kind of baseline, really, and similarly, a similar story in productivity as well. But interestingly, when you're developing a baseline, thinking about your pre-project stuff, it's really important to make sure that stuff that works really well is carried through. So the views are maintained, for example, or the wonderful heights of the labs and the lights. The project shouldn't compromise what works well. And getting an understanding of the pre-project elements is really important, I think, in terms of delivering a successful project in the end. And also, at the very earliest stages, we sat down with the end users, the guys that are going to operate the building as well, and through a number of facilitated workshops, developed up a number of themes that we use to measure the success of the building in use. So this is, interestingly, these are the 10 themes that we came up with. You see the usual suspects there in energy, water, waste and carbon, but actually for the university, of course, education and collaboration is really, really important for them. They need to be able to measure the success of the project against those elements, which isn't captured with frameworks such as BREEAM. So taking that, we developed a framework handbook that had all these themes and sub-themes in it, which they could use to measure and verify the performance of the project against those themes through the design stages, in construction and in operation. Just a few headline targets there that we talked about. So energy and carbon. So we're targeting a 40% reduction in operational carbon emissions. That is to say, that includes regulated and unregulated energy as well, over a pre-project baseline. Biodiversity was really important for the university, for obvious reasons, being the David Attenborough building. So at least 60% of the available roof to be given over to areas that promote biodiversity, green roofs, that kind of thing. And also really important to reduce water demand to 30% through fixtures and fittings and that kind of thing. Actually looking at the building in use, so just drilling down specifically into the energy aspects, I mean the building was using a hell of a lot of energy. So looking at benchmarks here, and this is the building in use compared to benchmarks like TM46, etc. It's using twice as much than what would be typical of a building. Also looking at the graph there, that's the energy meter readings over the course of 24 hours, and there's really quite a high base load at night, so the energy was being hemorrhaged outside of the occupied hours, which are the two dotted lines that crash down there. And the building was quite unique, we found, in that it had quite a lot of energy associated with servers, which was certainly skewing the results somewhat. So with that in mind, setting the targets, we took the whole building as is, operational, and decided to actually remove the server elements to create a baseline so that we could then compare this building with other buildings of that type. And it was from that baseline that we developed the 40% target that the building needed to meet. So how do we do that? So we developed an operational energy model. This is an IES model that looks to predict the energy in use more accurately than, say, building compliance modelling. And hopefully through that, we're able to minimise what's called the performance gap. So as designers, we predict what energy the building might use, but in reality, that's often quite a bit off the mark. So just to kind of reiterate on that in terms of the performance gap, the design stages typically would be used Partel modelling, which only concentrates on regulated energy. You need to think about the unregulated loads as well, because there are significant elements of the story. So make sure that you're developing your targets using that. So there's CIBSE TM54 that can be used, for example, for new builds, and TM22 for existing builds as a methodology to work that through. There are challenges through construction. Obviously, we need to make sure value engineering that occurs doesn't impact on the energy performance of the building. Also, the quality, the airtightness, build quality, and commissioning is really important. And I can't stress enough in terms of operation to engage with the end users as early as possible. And when I'm a soft landings champion, a visual soft landings champion, that provides a framework to help those conversations to happen. We know that there are issues around controls and BMS need to be addressed early on in the design stages. And just to reiterate, that Partel, that would be a building compliant building in terms of building regulations, the Partel result there, and it's so much less than actually how much energy a building would typically use. So in terms of the building itself, features, so fabric first approach, so we upgraded the fabric as much as possible, increased air tightness. You can see the photovoltaics there and the amount of green roofs that we're able to accommodate. I mean, the section through the building does create a lot of opportunity to bring natural daylight right into the belly of it as well. And it's a heavyweight 1960s building, so it had high thermal mass. That is to say, we can store the cool air at night, and that uses to offset the heat gains in the day. The upper floor didn't have the mass, so we used phase change materials to get the thermal mass up on the roof level there. So, in summary, I think that the opportunity is a retrofit challenge, refurbishment rather than demolish strategy is really important. Having a framework that ties in the end user requirements that can track through design, construction and operation is really important. So engagement with end users at the earliest stages, using passive design strategies to reduce the operating cost by 50%. And we're still committed to this project. We're carrying out a 2-year post-occupancy evaluation to see actually how the building is achieving the targets or not.
Okay, I think we're a bit short of time, so we've got another project called the Exeter Forum that if anyone's got any questions about, it's a really fabulous project that unites a lot of existing buildings and actually through the process improves the performance of the buildings that are around it. So if anyone's got any questions about the Exeter Forum, then just ask me afterwards and I'm happy to take those.